Hey students, this is lesson 10.1, the Pythagorean theorem. We are going to learn how to solve problems by using this thing called the Pythagorean theorem, which is one of the most amazing things in mathematics. So go ahead and do this review and I'll check back with you. Some important, really important words here that you need to know. In a right triangle, the longest side is called the hypotenuse. And the other two sides, the two shorter sides, are called the legs. The legs always form the right angle in a right triangle. And the hypotenuse is always across from or opposite the right angle. So the hypotenuse is the longest side in a right triangle. That's true. The hypotenuse of a triangle at the right has a length of 12. That is false. That's one of the legs. The legs of a right triangle can be any two of the three sides. That is also false. It has to be the two shorter sides. One leg of a triangle at right has the length 16. That's true. A longer leg is length 16. And the hypotenuse of a triangle at right has a length of 20. That's true. All right. So we're going to learn how to solve problems using Pythagorean's theorem. And I think in class we may explore a little bit more where this comes from, but in general, what the people that the Pythagoreans were given credit for this, what they discovered is that the area of the squares on the legs of any right triangle, so these areas A and B, will always add up to the area of the square on the hypotenuse, which in this case is C. So, and since you can find the area of a square by just doing A squared, A being the side length and of each of those squares, and B is the side length of square B, and little c is the side length of square C, then A squared plus B squared is equal to C squared. The diagram at right shows the sides of a right triangle with a square along each side. Count the number of square units in each region. So if we do that, we get 9 here, 16 here, and this one you'll notice is 5 by 5, which is 25. So 9, 16, 25. And we can add A plus B and it'll equal C, because 9 plus 16 is equal to 25. And that'll always happen when we have a right triangle. So let's use that idea here. And I'm just going to write it up here to help me remember what's going on here. And for a while, we should remember that we're talking about a right triangle. So with legs A and B and hypotenuse C. All right. So Anita is tiling the backsplash in her kitchen with triangular pieces of tile. If the sides of the triangle are 3 and 7, how long is the triangle's hypotenuse? So you're always going to want to maybe draw a picture for these. So we have we have triangular pieces of tile. The sides of the triangle are 3 and 7. How long is the triangle's hypotenuse? We have to assume this is a right triangle. So, so we're going to say that these are right triangular pieces. So, so 3 is our A, B is 7, and we're looking for C. And we know that A squared plus B squared is equal to C squared. So that means that we can substitute 3 for A and 7 for B. And we get C squared, and 3 squared plus 7 squared, that's 9 plus 49, which is 58, is equal to C squared. And using what we know about solving quadratic equations, we just want to take the square root of both sides of this, and we get C is equal to the square root of 58, which is about 7.6. And one thing you should always do when you're using Pythagorean's theorem is check to make sure that it is indeed the longest. So we just got that at 7.6. The other thing about triangles is this C could not be more than these two added together, because then it wouldn't be a triangle anymore. So kind of a checkpoint would be it has to be between 7 and 10. All right? So I'm going to let you try it here. Fill out this information, check back with your answer. Now, you probably remember from our doing quadratics that this would actually have two solutions, which are positive and negative square root of 225. But since we're talking about the length of the side of a triangle, we're always going to just want the positive one. All right, so what is the side length of B in triangle below? All right, again, A squared plus B squared is equal to C squared. And I would suggest you write this down because there's going to be some situations where the work you do is a little bit different. So in this case, our A is 7, A is a leg, and this is our C, and we're looking for B here. So we're going to substitute 7 for A. B is our missing, and 25 for C, so we get 49 plus B squared is equal to 625. And then we're going to subtract 49 from both sides. And we get B squared is equal to 576. And so now we're going to take the principal square root of 576. And I think that's 24. You may have to check my math, but I think 24 times 24 is 576. All right. You try it here. Here you just need to fill in a justification, and what I mean by that is here we're going to use Pythagorean theorem and so on. See if you could get the right reasons. You can check back with your answers. All right, the converse of the Pythagorean theorem is also true. Converse means basically you're talking about the formula backwards. So what we're saying here is that if you have three sides of a triangle and you don't know it's a right triangle, but you know that the three side lengths are such that A squared plus B squared equals C squared, then that's enough to know that the triangle is a right triangle with a hypotenuse length C. So a triangle with side lengths 12, 16, and 20 is, so what we want to do here is we want to do 12 squared plus 16 squared and see if that's equal to 20 squared. So that's just a question mark there now. So we'll check that. And 12 squared plus 16 squared is 400, and so is 20 squared, so they are equal. So it is a right triangle because 12 squared plus 16 squared is equal to 20 squared. A triangle with side lengths 9, 11, and 14, so we're going to do 9 squared plus 11 squared and see if that's equal to 14 squared. And it is not. 9 squared plus 11 squared is equal to 202. And 14 squared is equal to 196, so they're not equal, so it is not a right triangle. So let's try a couple problems here. All we need to do is check to see, and the hypotenuse is always going to be the longest of the three sides, so no matter what order they're written in, that's going to be your hypotenuse, which is C, and then the two shorter legs are interchangeable for A and B. So we want to test this. 5 squared plus 8 squared. See if it's equal to 10 squared. And 5 squared is 25 plus 64. That's 89, which is not equal to 100. So we're going to say not that one. Then we're going to do 9 squared plus 40 squared, which is 81 plus 1600, and see if that's equal to 41 squared. 41 squared is equal to 1681, which so is 81 plus 1600. So those are equal. So that one is the side lengths of a right triangle. Now I'm going to leave the other two for you to check and make sure they're see if they are or not. I don't know if there's more than one correct answer here. But go ahead and finish those up. You can check it out. Let's cross out the ones that we know aren't, and you can check the other two, cross them out if they're not right triangles. Go ahead and do 16 through 18. You can check back with your answer. All right, let's do the lesson check here. A student found that the length x in the triangle right by solving the equation 12 squared plus 13 squared equals x squared. Describe and correct the student's error. Circle the equation that correctly relates the sides. And that is 12 and x are the two shorter sides, so 12 and x would be a and b, and they should equal 13 squared, so that would be that one. And to do that one, we would have to do 13 squared minus 12 squared. So the student inadvertently replaced the hypotenuse with the leg. So to find x, we would do 144, 169, subtract 144 from both sides, and we get x squared equals 25, so x is equal to 5. All right, that's it. I'll see you tomorrow.